So I think I detailed the question last class, Abby. Let me just come again. You have the question already with you, Abby. So the question says a motorist whose car will not start seeks a tow from a second motorist. The tow vehicle accelerates slowly from rest with a low rope slick. When the rope becomes tight, the tow car starts to accelerate with a towing vehicle moving with a constant speed of what the 0.8 meter per second until the tow car of mass 1,000 kilogram achieve the same speed. Question one says, what is the change in what momentum of the tow car? Question two says, the average tension in the rope is assumed to be 9,000 Newton during the acceleration of the tow car. How far does the tow car travel from rest during its reach of the speed of 0.8 meters? Last question says, how far does the throwing vehicle travels this time? So let's get this done, please. So first, I'll get question A done. Someone is entering this stuff. Let's get question A done, please. Question I says, before I get this done, please, we said first, write out what you are given, Abby. What are we given the question there? It says, I'm giving just what? Speed and what? And mass, Abby. So I'm giving the mass as what? What's my mass there? 1,000 what? Kilogram, Abby. What next there? Velocity, speed, Abby. That velocity, Abby, is what? Is 0.8. Is 0.8 meter what there per second, Abby. So question A says find what? Change in what? Momentum, Abby. So find the what? Change in what? Momentum, Abby. So the change in momentum, that's change in P, Abby, is what? P2 minus what? P1, as we said initially from last class, Abby. What's P2? That's what? M2 V2 minus what? M1 V1. Abby? Or use U if you want to. Because we said you can't have two V. So use U here instead. So M and M, so they're the same thing, Abby. So it means that my change in momentum P is equal to what? M into what? V minus U, right? Now putting your values there, change in momentum P equal to what? What's your M? 1,000 into what's your V? 0.8 minus what? U is what? 0. Why is U 0? It was stated in the question that what is it there? What is it? It was stated in the question that I'm coming.
Towing vehicle accelerates slowly.
Not there. I'm coming. Yes. The towing vehicle accelerates slowly from rest with a what? With a tow rope slick, right?
Yes.
So when the body is at rest, it means that U is 0. So that's why you get 0 from there. So from here now, changing P will be equal to what? 1,000 into what? 0.8, Abby. So what's changing P? What do I have here? That's 800, Abby. 800, Abby.
Yes.
What's the unit there? Kilogram meter per what? Seconds. This is your momentum concept, Abby. So I'm done with question A, please. Is it correct?
Yes.
Let's do question B. Question A says this. Question B now says what?
The average tension of the rope is assumed to be 9,000.
So in question B, I'm giving force as what? 9,000 Newton. What next? During the acceleration of what? A tow. How far does the tow car travels from rest, Abby?
That's velocity 0.6.
So this is what? Is it velocity or U? Look up. 0 point what? Okay, 0.8 what? Mtaban what seconds, Abi? What next again? That's what, Abi. What are you looking for exactly? How far does the car travels? That's what? Distance. So look at what? Distance, x. Abi? Now look up. What is looking for distance? This one is under concept of motion. Distance can be looked in two ways. I have different formula for distance. Go back to your motion. S equal to what? Ut plus what? Half at square. Or I use S equal to what? U plus V over 2 into what there? T. Abi? Also note that we said V equal to what? U plus what? AS. Abi? It's correct? Is it AT? Is it AT or AS?
80.
So it was V square equal to what? U square plus what? AS. Yes. No, it's AX. Check. V square U square plus 2 2x. 2ax. 2x abi, it's 2x abi, like 2ax abi. I can see. So here with 2x abi, 2ax. Now look up. It depends. So these are all this one are that here contain x. Abi. So which one exactly we will be okay for us to look for x here? I'm only given first abi and what? Velocity abi and for what? S. From everything here, S I must know what my acceleration abi. So look at acceleration here abi. So for me now, I'll call for acceleration. Like from this and this now, which one I want to use? I have to use what? I have to know acceleration, Abi. Which one I want to use? This one is not really part of the major equation of motion, but these two here are compulsory, right? They are part of the important equation of motions, right? So now I'm looking for. I need to know acceleration first, Abi. So how do you get acceleration? Force is what? Mass times what there? Acceleration, Abi. Make acceleration subject. A is what or what there? F over what? M. What's your F? 9. What's your mass? 1000. Abi? So mass 1000. What's your acceleration here? 9 what there? Meter per second square. Abi? I know this one now. So I'm looking for what? X, Abi. So check. Basically, what will be our U here? Because they both ask you, Abi. So the easiest one for you to use now is to use this one. Yeah, now they give you time. Is there time here? No time. I can't use this man. So I'll use this one here. Right? So in this case now, I know V. I've gotten V at 0.8 Abi. Did I know U? What will be U in this case? U is 0 now. U is 0. So yeah, now for me, U is still what? Still 0 from the question. Like from the initial question. Right? So now what will I use here? I'll use this one now. So I'll now recall that we said V square equal to what? U square plus what? 2ax. Put your value here. What's your V? 0.8 Abi. So I have 0.8 all squared. What's your U? 0 Abi. So 0 squared is 0 is off. I'll run it again. So I have what? 2 into what's your A? 9. What's your X? Unknown yet. 0.8 squared is what? What do I have here? 0. What? 64 Abi. Multiply, so I have what the 18x. Abi. Let's get X here. What do you do to get X? From here now, I'll make X solid, Abi. So S now equal to what? 0.64 over what there? What's X here? 0.0 what? 3 what? In what? In meters. Come here. 3, yes. That's correct, please. That's correct, please. What next again? Find what's the last question there?
How far does the touring vehicle travel?
How far? That's time, Abby. That's what C. C says what? How far does what? Did what? Touring vehicle travel, Abby. That's time, Abby. Still yet C using what? Equation of motion, right? So what do we use initially? We can still use that same thing we use, Abby. No, it's not having T. So we should ask T. That upper I'll use, Abby. That's what? X equal to what? UT plus what? Half a t square, Abby. Basically, we cannot use this one now. Abby is having yes now UT. Yes now, yes. It's squared now, Abby. Yeah. If I start to use this one, I'm having double T here, Abby. Let's say you see another one that says what? V is equal to what? U plus what? AT squared. AT squared, right? Abi now? So observe that we see another that says what? V squared what? U squared plus what? 2ax. Abi? We see another that says what? X is what? U plus V over 2 into what? T. Abi? Depending on what we want to use. I can use this one, Abi. Yes, it work. Because I understand already now. Abi? I can say this one to work. U is 0 now. V is what? What's your V? Check. V is what? 0.8. Are we there? So I can see over 2. I'll look for T like this. So I can use inside this one or this one, none of my choice. So we can still go with this one, right? So I will not go with this one, Abi. So for C now, I'll go with this equation. So I will clean off. So no, it's like it's the same thing. Like this is just illustration to show which one to use. I can use this one and this, any of my choice. It's still okay. So for me now, all I get V. See there? U plus what? Plus V.
Yes.
Okay, over 2 into what? Into TRB. Or use which one? The first one. That V equal to what? U plus 2 80 square, Abi. So let's this one for instance. So what's this one? That's 0. What? 0.35, Abi. Into what's your U? Huh? 0 plus what's your V? 0.8 over 2. What's the T? Unknown yet. Have you seen this part? Copy down. So that's depend on how can you use those equation of motion to play. That's the concept. How can you use them? Just make sure you write them out, know them very well. Look up, please. We should have what? 0.035 equal to what? 0.8 Abi over 2 into what? T Abi. Divide this one that I have. 0.035 divided is what I have. Huh? 0.4 what? T. Get T. How? 0.4. 0.4. What's T? What's T? 0.087 seconds. Abi? That's your time. That's the time there. Yeah. Imagine. I said that. We said we can use it inside this one or what? You go to what? U plus what? 80. Abi? 80 squared. Abi? Is 80 squared? Just 80. It's 80, not 80 squared. It's 80. So I was trying to record this one then. So then I want to solve it with the one that has V square U square plus what? 2ax. I wanted to record this one. Let's copy this one. That's why you gave me this one. Either I use this one or I use this equation of motion. I'll get the same what? Answer. Right? So I can't use this one because there's no T here. There's no T here. I can't use this one. So that's your answer. We're done with this question, please. We're done with this.